How deep can you go?
We can go to 20,000 feet.
This is quite a mound.
Keep going. I think we just hit a home run. Got it. Now we go back here and they start telling us what we found.
For 60 years, scientists thought they understood the Puerto Rico Trench, that eerie blue wound slicing through the Atlantic. But when an AI finally mapped its full depth, it didn't find monsters or ancient cities. What it found was worse.
It's really confusing. The whole area is sort of like a jigsaw puzzle made up of these different rock types and different sort of land masses that we know very little about. So we're trying to put the jigsaw puzzle together and really figure out what the geological history of the whole area is.
It found proof that our entire model of the ocean floor, the way we think continents move, how pressure behaves, even what deepest really means, might be wrong. The data showed something moving where nothing should move, something bending the rules of physics itself. So, what exactly did this AI uncover down there? The first descent, when we thought we knew. By 1964, the Atlantic was supposed to be old news. Every oceanographer thought they knew its moods, its depths, its ghosts. But that year, a French vessel called Archimede slipped quietly into the Puerto Rican waters to prove otherwise. It looked like a small silver capsule built for daredevils, not scientists. And inside sat 3 men, Jean-Marie Perez and his crew, about to drop into the deepest part of the Atlantic Ocean, the Puerto Rico Trench. They descended slowly, at just 3 feet per second, a silent elevator ride into the planet's least forgiving neighborhood. For 2 hours, the light dimmed from turquoise to ink. The bathyscaphe groaned under pressure thousands of times stronger than at sea level, each creak reminding them that a single flaw could mean instant implosion. But then, at nearly 8,300 meters deep, where scientists believed nothing with bones could survive, their floodlights caught something moving. Through a narrow porthole lit by weak incandescent beams, they saw them. Dozens at first, then hundreds. About 200 ghostly white snailfish, drifting like lost souls in the dark. Real vertebrate fish, alive, swimming in a world thought to be biologically silent. This moment flipped everything we thought we knew about the Hadal Zone, the deep sea region beyond 6,000 meters, a place scientists once called the sterile frontier. Imagine being there, peering through a keyhole into a living dream that science said couldn't exist. The crew could barely believe it themselves. These snailfish, members of the Leparidae family, became instant legends. Their survival wasn't just strange, it was revolutionary. If vertebrates could adapt to those crushing depths, what else could be hiding in the trenches of the Atlantic? Jean-Marie Perez published the findings soon after, and the world listened. For decades, biology textbooks repeated the tale of those 200 snailfish spotted during a 1-mile transect of the Puerto Rico Trench. That single observation became scientific canon. It declared that complex life could indeed thrive under nearly 8 kilometers of water and unimaginable pressure. The Archimedes dive turned this trench into a symbol of possibility, a reminder that the ocean still held secrets worth chasing. But for all its fame, few realize how little they truly saw. Archimedes' tools were primitive by modern standards. Its lights were weak, its cameras grainy, and its windows small. Every sighting was a blink through fog. The team wasn't capturing a full picture of the deep. They were glimpsing it through a soda straw. Yet those glimpses shaped half a century of ocean science. The trench itself sits north of Puerto Rico and the Virgin Islands, marking where the Caribbean plate slides beneath the North American plate. Its deepest point, the Brownson Deep, plunges 8,376 meters, making it the Atlantic's final abyss. And beneath all that water, the trench hides something else. The largest negative gravity anomaly on Earth, a baffling -380 milligal dip so strong it can make compasses spin and navigation systems fail. Sailors call it the Atlantic's second Bermuda Triangle. For decades, that mix of wonder and danger built the trench's legend. Scientists thought they understood its creatures, its pull, its story. But now, 60 years later, AI scanners are revealing that maybe they didn't. What if those ghostly fish weren't the strangest thing down there? What if the Archimede barely scratched the surface of what's really hiding in the Puerto Rico Trench? The AI returns, correcting 60 years of history. For 60 years, the Puerto Rico Trench was like a sealed chapter, one we thought we'd already read cover to cover. But in 2018, a billionaire explorer decided to reopen it. His name was Victor Vescovo, and his goal wasn't just bold, it was record-shattering. He called it the Five Deeps Expedition, a mission to reach the deepest point in every ocean on Earth. And on December 19, 2018, his titanium submersible, the DSV limiting factor, became the first human craft to touch the deepest known point of the Atlantic. The Brownson Deep, 8,376 meters below the surface. That's nearly 27,500 feet down, a place where sunlight has never existed, and even sound moves differently. Now, this wasn't some 1960s steel capsule with fogged-up portholes. The limiting factor was a full ocean-depth submersible, built to withstand 16,000 pounds of pressure per square inch. Its spherical titanium hull was like a mini spaceship, engineered to laugh in the face of the abyss. And on board, Vescovo had something no human explorer before him had ever used: artificial intelligence. This AI wasn't there to drive the sub, it was there to see. Using 4K imaging systems and machine learning software capable of recognizing deep-sea species in real time, it turned the ocean floor into data, pixel by pixel, pulse by pulse. The system cross-referenced what it saw against a massive global library called FathomNet, a database built from over 28,000 hours of deep-sea footage and 8 million annotated examples. Think of it as the Google Photos of the abyss, except instead of tagging your vacation selfies, it was classifying organisms so strange they barely had names. Vescovo's team didn't just explore new ground, they retraced old ones. Using historical dive logs, they zeroed in on the exact coordinates of the Archimedes' legendary 1964 descent. They wanted to test the story that had defined deep ocean biology for decades, the discovery of those mysterious Hadal snailfish. And when their cameras rolled, what they found sent shockwaves through the science world. Because there were no snailfish. Not one. Instead, the seafloor looked alive with slow, pulsating forms, pale, leathery sea cucumbers known as peniagone. Thousands of them, each about a meter apart. The density matched exactly what the French team had reported 60 years earlier. The same number, the same color, the same shimmering movement. But the AI saw what human eyes couldn't through that old porthole glass. Those fish weren't fish at all. The realization was brutal. In 2020, the findings were published. The reported Hadal snailfish of the Puerto Rico Trench was in fact a misidentification. Decades of textbooks, documentaries, and scientific models, all built on a visual error made under crushing pressure, dim light, and 1960s technology. And yet, it wasn't failure. It was human. Those early explorers weren't wrong. They were just working with the tools they had. Their portholes were the size of dinner plates. Their lights could barely pierce the black. Under those conditions, A white sea cucumber drifting on a current looks exactly like a ghostly fish gliding by. But here's where it gets really interesting. AI doesn't blink. It doesn't guess. It doesn't get fooled by shadows or pressure distortions. It analyzes morphology, texture, and movement with microscopic precision, and it never gets tired. Where it once took human biologists weeks to identify a single species from a grainy video, AI can now process hours of footage in seconds, tagging species with near-perfect accuracy. The abyss is finally giving up its secrets, and we're starting to see how much we've gotten wrong. So if 60 years of ocean science could be rewritten by a single AI dive, what happens when the next generation of these machines starts mapping the rest of the ocean floor? What else might we have misidentified? Or worse, completely missed? The new generation. How AI is really scanning the abyss. By mid-2022, the legend of the Puerto Rico Trench was alive again. But this time, the descent didn't belong to a billionaire or a steel relic from the 60s. It belonged to Alvin, the legendary deep-diving sub that had just been reborn. During July and August, it embarked on a science verification expedition that would make history. 5 dives, each pushing to an insane 6,453 meters, deeper than any human-piloted dive Alvin had ever attempted. Imagine being sealed inside a titanium sphere, no wider than your living room table, descending into crushing blackness where pressure could turn a soda can into dust. That's where Alvin went, armed not just with courage, but with AI. The newly upgraded Alvin wasn't the same craft that found the Titanic in the 80s. It came back rebuilt, outfitted with 4K imaging systems, laser-guided navigation, autonomous sampling arms, and an AI-assisted command brain that learnt from its environment as it explored. The result? For the first time, scientists could see and think in real time at 6.5 kilometers down. And what Alvin found was jaw-dropping. On the trench's slope, its robotic arms brushed across exposed oceanic crust dating back 100 million years, a literal time capsule of Earth's tectonic heartbeat. Then came the real shock. Alvin's sensors recorded bursts of heat and shimmering columns in the dark. As the sub glided closer, its lights revealed something scientists had never seen in the Atlantic. Active hydrothermal vents, black smoker chimneys belching fluids hotter than 400 degrees Celsius, like underwater volcanoes spewing darkness itself. And around them, life. Entire colonies of chemosynthetic creatures feeding on chemical energy instead of sunlight, glowing like sparks in an eternal night. Alvin's cameras captured the deepest known specimens of multiple species, life forms operating completely outside our definition of normal biology. It was official. The Puerto Rico Trench wasn't dead rock. It was alive, ancient, and boiling from within. But Alvin's AI-assisted systems were just one small piece of a much larger revolution happening right now across the oceans. At MIT's Lincoln Laboratory, engineers developed something that sounds straight out of science fiction: the autonomous sparse-aperture multibeam echo sounder. Picture this: 20 small autonomous vessels scattered across the surface, working together like a synchronized swarm. Each ship fires sonar pulses downward, and their signals merge into one massive, high-resolution map of the seafloor. These vessels communicate wirelessly, adjusting formation on the fly, and the results are wild: a 50 times faster coverage rate and 100 times better resolution than traditional ship sonar. With this, scientists could literally map the entire ocean floor faster than we mapped the moon. Meanwhile, NOAA's deployable AI systems now patrol deep-sea missions in real time, analyzing live video feeds from remotely operated vehicles. Trained on FathomNet's ocean database, these systems can instantly recognize species, tag them, and even flag unusual activity before a human operator could blink. Another NOAA project used machine learning to scan 428,396 manually labeled sonar images, detecting over 6,500 gas seeps that humans would have taken months to identify. In other words, AI is now reading the ocean floor the way your phone's camera reads faces. And it's not just about biology. In Puerto Rico's seismic zone, deep learning models like EQ Transformer have combed through 3 years of data, identifying 180,000 earthquakes, 7 times more than human analysts had ever found. The result was a revelation. The area beneath Puerto Rico isn't one clean fault line. It's a tangled, multi-layered system of ruptures, shifting in ways we've never fully grasped. That's the real story here. AI isn't creating new discoveries. It's showing us the complexity that was always there, hidden beneath human limits. The ocean floor, once blurrier than the surface of Mars, is suddenly becoming the most detailed landscape we've ever mapped. Yet, with every scan, every sonar ping, every algorithmic discovery, one truth keeps surfacing. The more we see, the less we actually understand. Because if AI can expose this much life and chaos in a trench we thought we'd already conquered, then what happens when it scans somewhere no human has ever looked? The real terrors, what the AI actually found. April 2023. The Atlantic looked calm, but under that peace, science was about to break open a nightmare we didn't even know was real. A joint team from the USGS and the University of Puerto Rico drilled deep into a quiet mangrove pond near East Bajura, far from the tourist beaches. They were collecting sediment cores, thin cylinders of ancient mud that hold thousands of years of history, layer by layer. What they pulled out didn't look special at first, until one of the cores split open and revealed a half-meter-thick layer of sand packed with seashells, coral fragments, and shattered land debris. It didn't belong there. It was the fingerprint of a tsunami. When they sliced through it in the lab, every layer told the same violent story. The base was scoured clean, meaning water had ripped across it with unstoppable force. The grains got finer upward, showing the waves retreating, dropping heavier material first and lighter last. Radiocarbon dating fixed it between 1470 and 1530 CE, centuries before Columbus ever set sail, when no written Caribbean records existed. That's when AI entered the picture. Geologists ran the core data through a deep learning model trained on hundreds of known tsunami signatures. The algorithm ran every simulation possible: wind, storm surge, landslide, and every scenario failed except one: a mega-thrust earthquake along the Puerto Rico Trench with a magnitude between 8.7 and 9.0. To put that into perspective, that's larger than the 2011 Tohoku quake that triggered the Fukushima disaster. The rupture length needed? Around 350 kilometers, almost the entire northern edge of Puerto Rico. And this wasn't just theory. A separate team studying coral boulders in the Virgin Islands found monstrous blocks weighing tons sitting over a kilometer inland. Some dated to 1200 to 1480 CE, the same window. No hurricane could have done that. Only a tsunami could. The terrifying truth? The Puerto Rico Trench doesn't just shake. It occasionally snaps hard enough to rewrite coastlines. And with 3.4 million people living along Puerto Rico's shores, a repeat event could reach land in less than 20 minutes. Today's warning systems might not even buy that much time. But while AI was decoding the past, it was also uncovering something stranger in the present. What's living down there? In 6,000-meter-deep samples, scientists isolated a microbe named Profundimonas piezophila. It's an obligate psychropiezophile, meaning it can't survive without extreme pressure and cold. Bring it to the surface, and its cells literally collapse. It dies not from lack of oxygen, but from lack of weight. Its biochemistry is so alien, it's rewriting what we thought life could be. Deeper still, single-cell genomes from 8,219 meters showed genes for trace gas oxidation, heavy metal detox, and complex carbohydrate digestion, adaptations never seen before. The trench floor that once looked barren now appears as dense as a rainforest, with sea cucumbers spaced roughly 1 per square meter, a biomass greater than some coral reefs. Cameras captured black corals, sponges, colonial tunicates, and even a bryozoan species no one had seen since 1933. And then came 2025. AI-driven submersibles recorded signs of petite spot volcanism, tiny eruptions bubbling up through tectonic cracks, thought impossible here. It means the Puerto Rico Trench isn't just tectonic. It's alive and changing from beneath. Each dive brings back fragments of new species, and plastic bags, fishing lines, and microfibers drifting beside them. We've reached the deepest part of the Atlantic with pollution before we've reached it with understanding. So, if AI has already revealed evidence of ancient tsunamis, alien microbes, and hidden volcanoes beneath our feet, what happens when it turns its sensors toward the unknown structures lurking in the trench's darkest regions? The epistemological abyss. What it means to be wrong. The strangest part about the Puerto Rico Trench story isn't the alien microbes or the hidden volcanoes. It's the moment AI told scientists they'd been looking at the wrong creature entirely. For years, research papers, textbooks, and even documentaries proudly showcased footage of a snailfish gliding across the trench floor. It was proof, they said, that vertebrate life had conquered the deepest Atlantic. Except, it wasn't a snailfish at all. It was a sea cucumber. That one mistake, snailfish turned slug, sounds small, but it's a crack that runs straight through the walls of modern science. It mirrors a deeper pattern stretching back decades. In 1960, during the legendary Trieste expedition to the Mariana Trench, explorers reported seeing a flatfish drifting at nearly 11,000 meters deep. The idea electrified biology. A fish that far down meant bones could endure unimaginable pressure. But later analysis suggested it wasn't a fish at all, just a trick of light and silt. A sea cucumber again. The debate still lingers in oceanographic circles like an old ghost. These errors reveal how fragile our knowledge can be when it's built on blurred screens and shaky sonar. A single misread shadow becomes an entire research field. Imagine this. For years, grant proposals were written to study how vertebrate fish adapted to Hadal Atlantic conditions. Grants, budgets, PhDs, all orbiting a case of mistaken identity. The AI didn't just correct a name, it quietly pulled the rug out from under an entire branch of marine biology. So, what happens to scientific truth when our eyes themselves can't be trusted? We've mapped the ocean floor with higher resolution than Mars, yet most of it remains a mystery, 95% unexplored. And the darker truth? It's not just that we haven't looked. It's that when we do, we often see wrong. Our tools, our lighting, our interpretations, they bend reality like the trench's own gravity anomaly, warping what's true until AI finally straightens it out. And when AI did look straight, It found chaos beneath our confidence. It detected 180,000 earthquakes, where human analysts only saw 26,000. It spotted thousands of gas seeps, corrected species IDs that had sat in journals for decades, and exposed how much we missed simply because we were tired, biased, or limited by bandwidth. The technology didn't just enhance our vision, it humbled it. The uncomfortable truth? Ocean exploration isn't in its golden age, it's in its infancy. We're not breaking new ground, we're relearning old lessons with better lenses. And that's not a failure of past scientists, it's a reminder of how alien this world still is. But it raises a terrifying question. If we got something this basic wrong, what else have we misunderstood about what's actually moving down there? If an AI can see what even our best submarines missed, what else lies beneath those crushing miles of dark water? NOAA's next expeditions and FathomNet's machine learning dives are already mapping new worlds right here on Earth, worlds we barely understand. Each ping, each sonar flash could rewrite ocean history. But here's the real question. If this AI found motion where there should be silence, what happens when it finds sound? And who or what might be making it?